So today we're going to look at data sources that can be used with Design Studio. So some of our colleagues have previously given in-depth webinars on Design Studio. So we will simply be focusing on the use of the application to connect to various data sources and how they are configured on BIP. So in this, we'll take a step back maybe and look at the rationale or the context in which we're doing this. And so we'll talk about online analytical processing versus transaction processing, and some commonly used terms and definitions, for example, data warehouse, data mart, and typical landscapes that are used to extract the data into the data warehouse and the cubes for reporting. Some of the patterns that you'll see are due to the evolution of the SAP product line through acquisitions and also through developments such as SAP HANA. So we'll have a look at some of the how the common concepts apply to all these different systems and platforms. Again, we'll have a look at some BW terms and definitions and provide some links to resources that can be helpful in understanding these. We'll also talk a bit about the HANA views that can be connected to as well. Then I'll have a couple of demos of using BIP to set up the OLAP connections, both for BW and for HANA. And then my colleague Sinead will go into talk about OLTP and universes and connection using the semantic layer to OLTP systems. So just very briefly, what is Design Studio? It's a client tool from SAP's product line that allows a connection to a variety of data source types. So in summary, the data source types could be considered as analytic OLAP sources either on BW or HANA, OLTP database access through a semantic layer, which is implemented as a universe on SAP's BI platform. And also, there's the possibility with Design Studio now of real-time streaming using a WebSocket interface. Just to summarize, with the Design Studio client, it can access data sources through a variety of runtime options, mainly through the Business Intelligence platform, but you can connect the Design Studio Designer client directly to some backend systems and run in local mode. There's limited support for the SAP NetWeaver platform with Design Studio, and I understand in future the platform going forward will be Business Intelligence Platform, BIP. So just to get into the details of this OLTP versus OLAP, online transaction processing is characterized by systems where you have a lot of short online transactions, usually used for running the day-to-day business. Fast query processing is required, multi-access environment, several users, high transactions per second. And the database model is usually in what's called third normal form. In comparison, the OLAP model is characterized by relatively low volume of transactions. So in this case, you're not looking at the day-to-day operational running of the business, but rather looking at how the business is performing over a period of time. So what you're looking for is trends, patterns, and so for that you need a large volume of consolidated data, and typically this is done or has been done in the past by aggregating data from OLTP systems into analytic cubes. For OLAP systems, response time is a measure of effectiveness. They're used in data mining applications, and usually the data model is based on the star schema, and data is stored in multi-dimensional cubes. So a comparison in terms of a number of different parameters. The source of data for OLTP would be the operational systems used to run your business day to day. In OLAP, this data is consolidated by extraction from the OLTP systems into a separate system or systems. The purpose, as we said before, is the running of the business on a day-to-day basis is the main purpose of the OLTP pattern, and the OLAP in comparison is used for long-term planning, decision support and so on. Typically very fast processing speed in OLTP, and traditionally OLAP had slower response time due to the requirement to load large volumes of data into a back-end system. Of course, this was one of the motivations for the development of the HANA system, where the data is loaded into memory and query speed is improved dramatically. Database design comparison is third normal form in OLTP, and typically in OLAP you have a star schema, which means you have one table with the fact table or measures, and the tables related to it are the parameters or dimensions along which you want to analyze your business. In terms of queries on the data, in OLTP, the queries are relatively straightforward, returning a small number of records, whereas in OLAP, the queries can be very complex due to aggregations and hierarchical data, drill downs, and different patterns of slicing and dicing, as it's called, the data. Just to give an idea of how the data goes from the OLTP systems through to the OLAP system, you go through a process of what's called extraction and staging and cleansing. I think the term used is extract, transform, and load into a data warehouse. The data warehouse contains the consolidated data, and the data mart would typically be sections of the data warehouse grouped by functional area to allow a limited subset of data for analytic reporting. So this would be the general or generic pattern, and then we define the data warehouse, also known as enterprise data warehouse, and typically you're looking at running reports on annual and quarterly data, looking for trends. Data is uploaded from the operational systems, and as I said, the data mart is a slice or a layer through the data warehouse on a particular functional area for analytic reporting. So we delve into OLAP a little bit more, as this is what we'll focus on in our demos on setting up OLAP connections. So the terminology used is the OLAP cube, a multi-dimensional cube or hypercube, and basically the numeric facts on which you are interested in your business are called measures, and they're categorized by dimensions. And as I said, typically created from a star schema with a number of dimensional tables. So we have a fact table with, for example, sales data, which has a number of parameters that describe it, and the dimension tables then can again be broken down by dimension members such as market ID, city, state, and region, and so on. The terminology that's used and can be difficult for newcomers is BW has its own terminology, such as key figures, which are measures, and dimensions are characteristics. So this is one of the aspects I found difficult coming to this subject, and the terms in BW that you come across typically are data stores, info cubes, info objects, staging, and so on. So staging is the process of extracting the data from the OLTP systems into the cube systems. The data targets are data stores, info cubes are objects, The info cube has a multi-dimensional structure, and the info object is the smallest unit of BI data. And other terms used are info providers, which can either be physical sources of data or logical views on such data. So in HANA then, we come across the same concept. An analytic view in HANA is the equivalent of the OLAP cube. An attribute view corresponds to the dimensions or the characteristics in BW, and a calculation view is a composite view on top of these views. So now I'll show how we can set up some of these connections, first on BW and view them through the Design Studio Designer, and then also on some HANA connections. So first of all, I'll open my HANA. So this is a HANA system here, and you can see in the content section, you open it up, you can see the different types of views: attributes views, analytic views, and calculation views. So for example, if we take the Food Mart one here and look at some of the data on it, we can see it has what we talked about earlier, measures. For example, the store sales, and we could characterize it by how is it broken down by city or by gender as well. So these are your dimensions. So the idea is that you have the values axis with the measures, and the label axis will have the dimensions. And we can see we're looking at this system here, XCT, and this is an analytic view on that. So how do we go about setting this up on our BIP system to view it through Design Studio? So if I go to my CMC home here, log in. So here on the Central Management Console homepage, you can see the option down here for setting up OLAP connections. So if we select that and go into this folder here, you can see I've already set up some connections here, but I'll go through the process of how you would do it. So we'd set up a new connection. We'll call it Webinar 2. And you can see here the different types of providers. So you can connect to a warehouse, you could connect to HANA via two different methods. One is HTTP service, which is the INA service, or using an ODBC interface. So first of all, we'll connect to the BW system. We'll connect to a system called Q99. We give it the server ID. System number 69 is 0. And we'll select predefined, which is username, password, logon. And hopefully we can connect. We see it will take some time to connect and display the potential data sources that we can connect to. Okay, so we'll search for a particular one. And we'll select the first one here and save. So now in here in this folder I should have a Webinar 2. So it's our new connection to the BW system. And if I go to my Design Studio client application, which is connected to this BIP platform, and go into the Preferences section, I can see the backend connections that are already set up, but I don't see my new one here because I need to reload it. And hopefully when I reload it, we will see the second one up. Webinar 2, there we go there. So it's up at the top. and then okay, just go back into it and you should be able to see in the backend connection section webinar 2 has been added. So now with the second webinar 2, when I go to create an application, if I go to add a data source, I can browse the data sources here and I should be able to see my webinar 2 here, which is my BW connection. Okay, in a similar way then on BIP, as I said, we can create connections to HANA backend systems as well. So this is a connection to the INA service which needs to be set up on your HANA system. So we put in our details of our HANA system. And the port number that the service is running on. We give it a name. Call it 3. And just make a distinction that it's an INA connection. Predefined. And hopefully, yes, we can see there the list of data sources or cubes, analytic cubes on the HANA system that we can connect to. We've selected one, we save it, and again, when I open the folder here, we should be able to see that it now appears as the list of connections. And when I go to Design Studio and reload the connections in the Preferences section, once again, and so you open the Preferences section and look at the backend connections. Now again, you see you need to reload the connections to make the connection to HANA that we just created visible. And you see it appears in this box down here, HANA connections. And again, we can use that in our application creation. So if I add a data source, I should be able to see an increased list of data sources there. So there it is, there, webinar 3_INA. So that's the process of creating your connections to BW and HANA using BIP and seeing them in your Design Studio client for inclusion in your applications. And now my colleague Sinead will talk about the universe connection type.
So I'm going to be discussing universes and the other data source types other than BW. So it seems hard to believe, but BW has only existed since 1999. But before that, all of our systems that we would have been using were mainly online transactional processing. So this is referring to a class of systems really for transaction-oriented applications. So it was more geared to fast data entry and retrieval of transactional processing. So in an OLTP database, there will be detailed and current data. So the schema used to store this transactional data is the entity relationship model. So I just In a few seconds you should see the screen. But I included a really basic model of an entity relationship model. So you can see the structure of the table, and you can see how it differs from a BW or a BI type system. So we have a problem if our data is stored in that format. The problem is, how do we get this data into a format that's suitable for BI reporting? So I chose this diagram in particular because you can see the very different types of source systems that you can potentially have your data stored in. So, how to make the relational data suitable for the BI reporting? You can load the data from the OLTP system into a BW system as Des described, and that will eventually load the data into a format suitable for BI reporting. Or there is another option. This is to use what we call a universe. So this may be particularly useful if you have no BW system, but you use business objects, or in cases where you have many different types of systems that you want to collect data from. So, what's a universe? So it's a semantic layer. So it takes the data it uses business language rather than data language to access, manipulate, and organize the data. So pretty much very similar to how the BW system stores data. So it's stored as objects in a universe file. So we have Design Studio, Web Intelligence, Crystal Reports, and other applications use universes to simplify the user creation process required for simple to complex queries. So if you would like to use universes, you will need your business intelligence platform. So they're a core component. So in this diagram, we can see the BI platform 4.1 architecture. So you can see how this fits in with your reporting databases. All of your universe objects and connections are stored and secured in the central repository by the connection server. So the client tools for designing universes need to log into the BI platform to access and create universes. So I have a little bit more information on how this works just at the bottom of this slide. So I'll be going into this a little bit more detail in a few minutes. The tool that we actually use now for creating the universe is provided with the SAP Business Intelligence client tools, and it's the Information Designer tool. It's known as it in some documents, but if you're logging into it from your system, you'll see that it's called the Information Design tool. Now, from within here, you'll see that your universe is made up of different parts. You'll have to set up the connection first, then you'll set up your data foundation and business layers, and I've provided a link here to the Information Designer tool PDF, the documentation for that, just to give you a bit more information. All of your universes that are created with this Information Design tool will have .unx at the end, but within this tool, you can convert the older universes to UNX. While the Information Design tool will create and used to make changes to your universe and to the connection. We can see the connection from the central management console when this is being set up. So you can set authorizations in the central management console for this connection, and sometimes the parameters or other settings are required to be set within the business intelligence servers within the CMC. So first we can see that we have a project here. So this is a local workspace that contains the resources used to build a universe or more than one universe. So you can share this so that multiple designers can work on the same resources. So you don't need to have authentication to use this in offline mode, so just within the local project. But this means that it's not connected to a repository, so your business intelligence system. But the IDT or any client will need access to the central management console to access and create universes. So you've got a number of different steps to set this up. The first step is setting up the connection, and there's different prerequisites depending on the type of data source you want to use and which connection type you want to use. So here I've just provided some information here on the different components from the data access connection, and I'll be showing this in a few seconds, hopefully in a demo. And I just wanted to provide information here on the configuration files and how this all fits in together with the drivers. So that's the database specific software component that manages the connection between your connection server and your database middleware. And I'll also share my experience and some little issues that I came across recently when I was setting up some systems for some testing I was doing. The first thing that you want to be able to do is to make sure that your data access drivers and middleware software are configured for the data sources that you want to connect to. Then you'll hear the term secure connections. So these secure connections are connections that have been created in or published to a repository. So you can see in my slides here that we have, I don't know, you can't see my mouse move, can you? I think it's going to be too late by the time you see it. Oh yes, you can see my mouse. So I'm pointing towards the little icon, which means that this is a secure connection. So a normal connection won't have this little white box on the right hand side of it. So that means it's a secured connection, but I'll be showing you proper connections within a live system in a second. Secure connections are stored in a dedicated connections folder in the repository in the business object system that you're storing it in. So you'll see it as a connection shortcut exactly as you can in this little diagram. So there are also settings that you can set in the preferences of the information design tool, which means that you can decide if the local, so local means where you're running your client from, in this case Design Studio, or you can use the server, your BIP settings, to be used for the middleware of the secure connections. So for example, I had to install Oracle client software and make sure that my drivers were all set up in the server where I installed my business information, my BIP platform. And this can prevent problems with the middleware not being installed on one server, so locally. So the repository server middleware is used instead. So that means you only have to set this up once and install it once. So this only works if the download connection locally write is granted in the CMC for the connection. The next step is the data foundation layer. So it should come up on your screens in a few seconds. So once the connection has been configured, you need to set the data foundation from the connection or the secure connection if this has been set. So you can see from the little diagram, hopefully you can get an idea that I right-clicked on my secure connection in my project and I clicked on New Data Foundation. So the data foundation is just a schema that defines the relevant tables and joins from one or more relational connections. It's at this stage that you decide whether you want one data source on your universe or whether you want a number of data sources together. So you can take from a number of connections and you can take a number of tables from each of these connections into your data foundation and eventually the full universe. So in a few seconds I explain a little bit more about multi-source or single source. The delay is just coming up on your screen. Okay, so this just explains why it has to be set up differently at that stage. So you have to decide whether you're going to be using either database-specific SQL syntax or if you need to add more than one option so that you're not just using language for one database. We have other options at this stage. We can set parameters or lists of values at this stage, but they can also be defined in the next stage when you're setting up your business layer. So I've just explained here what a parameter and a list of values are. So the most common usage of the list of values that I've seen would be to use information or to use this information for a prompt. So that if you use a prompt when you're selecting your data to restrict your data that you're bringing back when you access this universe in a report, then you can allow the client or whoever's accessing this to select from a specific list of data. So a parameter is just a variable in the universe that requires a value at query time. This is referred to as prompts, but the list of values then can be used to choose the values for a prompt. So they would be inherited by all business layers based on that data foundation. So the next stage then would be to create the business layer. This is the metadata object layer would be called the business layer. So again, from the previous step from your data foundation layer, you right click on this to create your new business layer. So in this business layer, I've showed a little example here of you can create and run queries to validate and test the universe. So this is quite useful to do within here. So you can get an expectation, especially useful if you're perhaps joining data sources. You can get an idea of what data you can expect to get back in your eventual report. So once we've done that, how do we create the universe itself? For the business layer to become the universe, you must publish it. So you can see where you right click on it and then click publish. So you can either publish to a repository or a local folder. So business layers based on local connections must be published to a folder on the local file system. So later you can publish the resulting local universe to a repository. So if you have a business layer with one or more secure connections, it must be published to the repository on the same central management system where the secure connections are stored. So then if the universe is published to the repository, then you can see this in the folders, and it can be opened with a client like Design Studio. In a few seconds, you'll see some possible problems and how to solve them. Now, I very much hope that no one will get these particular issues. So, for the live demo, and this was especially embarrassing since I started my career as an Oracle DBA, I forgot to install the client software on the server that the BIP is installed on, which is also where I installed the BI client tools, where I ran my information design tool from. So my system didn't have the libraries to be able to talk to the Oracle data source. So that's a rookie error, and even though I've been working as a DBA, I made the error. Okay, so because I'd previously run this on my local server, which already had an Oracle client installed in it, so I thought it worked. So I also had to make sure that the configuration files were correct for the drivers and that they directed to the directories where the driver software was installed. I did get an error with connecting the MSSQL data source using the JDBC connector, and I had to add a parameter to the adaptive processing server and then to restart it. I also had restarted my system and didn't realize that the connection server hadn't restarted, so none of my connections would work. So that's just something to check when you're troubleshooting issues. And so I've put guides, SCN articles, and SAP notes to help with all of these steps. I think it's sometimes very useful to have all this information in one place. So I list some of the sources in the next slide. So hopefully you can see I'm just opening my client tools, and then I'm going to my information design tool. Okay, so I'm just going to connect into my repository here, okay, and we can see in here that I have 3 connections set up in here for a data foundation layer. So I only have 2 tables, so it's possible to do that as well. Okay, so, right. So here are some of my connections. Okay, I just wanted to show you something in here just quickly. A lot of drivers in the software, depending on your license, will be installed with your business object system, so they will become available. So we can see some of the options here for drivers here. So for Oracle 11, I have JDBC, ODBC, and the Oracle client. Within here, when we set these up, I use JDBC. So I have to set up details for my database, so my database user and password, the server host and port, so you get an idea of what I've set here. So there's my server host and port. So I just did a fully qualified server name, so I actually put it into the hosts file on the server as well, so that to make sure that it could recognize it. And if you have some difficulties with this connection, it's an idea to see if you can ping the server from here as well. And also check the environment variables. Different systems will require different things on your server. There's different requirements. And if I just go to show you quickly here. Right, so I also want to show you, go quickly to my SAP Business Objects installation folder. So it should come up in a second. Then I'm going to my connection server. So we can see within the connection server, hopefully in a few seconds, in a directory here, we can see some of the driver software, my Java driver software here. So within my connection server as well, I have within the JDBC, it will be different for the different connectors, but I have my parameter files in here. So I just want to show you quickly one parameter file. So I listed in the presentation what the difference between these parameter files are. So this is where I had to make sure that my path was set for my driver, for the driver software. So that's when I set up originally. And if I go back to the IDT and test the connection here, if I show the details, you should see that the SBO files and the PRM are stored in the folder that I just showed you, and that you should see what driver I'm using, the driver version, and you also, once that comes in and these are correct, you should know that it's all pointing to the correct direction. So this is as well the library, which is what I was talking about, that the systems can talk to each other as well. So here's the location of that, the data access GBG, drivers Java, DBG Oracle. So once that's working, you know that you can then set up your data foundation layer and then your business layer.